And when we graph that, we're going to then identify these pieces of information here, right? So we want to be able to determine all these little aspects here. So let's go to someone. All right, well, let's go to Leon. What is the domain of f of x equals x? Just look at the graph. What's the farthest left it looks like that graph is going to go? Negative infinity. You got it. And what's the farthest right it looks like it will go? Positive infinity. You got that, Leon. Exactly right. Okay. And then parenthesis, parenthesis, right? Okay, just like that. Yep, no trick questions here. All right, how about Christian? What about the range for this, Christian? What's the lowest, right? The lowest is going to go? Negative infinity. And then the highest? Infinity. Oops, my comma there. Got out of control. There it is. Okay, negative infinity to infinity. And the end behavior, I remember for end behavior, we write, as x approaches infinity. So as we go really far to the right, as we go really far to the right, what are the y values doing? So let's go to Lindsay. As we go really far to the right on our graph, the y values are going going to what value? Yep, infinity. Okay. And as we go really far to the left, Lindsay, right, as we approach negative infinity, the f of x, oops, that's supposed to be an arrow there. F of x is approaching negative infinity, right? Okay, so make sure you get those down, right? Okay, especially, if you need to refer to this here. Okay, so there's our first function, f of x. All right, we'll extend this now. And let's do another function here. Okay, the one we just did last unit, x squared. All right, we're going to skip absolute value. Absolute value doesn't really count as a polynomial, okay? It's kind of a thing unto itself, all right? So we're doing the x, bless you, the x squared, the x cubed, bless you, and then we'll do x to the fourth and x to the fifth as well. So let's take a look here at x squared. Okay, graph it. And there's x squared, okay? So let's see here. Garrison, what is the domain of x squared? Negative infinity to infinity. That's right. We're going all the way to the left. We're going all the way to the right. Okay? You got it. Okay. Thanks, Garrison. Let's see here. Jacob, well, you're the only Jacob here today. What's the range?
0 to infinity.
Yeah, great job. Very good. Yeah, different than x, right? 0, including the 0 to infinity, like that. Okay, so make sure you put that square bracket for the 0 to abbreviate there. All right. And then we'll do our end behavior as x goes to infinity, f of x goes to something, and as x goes to negative infinity, f of x will go to something as well. All right, let's go to who's going to help us with end behavior. It's going to be Destiny. All right, so Destiny, as we go really far to the right on our graph here, as we go further and further to the right here, Destiny, okay, what are our y values approaching? Yeah, you got it. Yep. And as we go really far to the left here, Destiny, what are the y values approaching? Infinity again. You got it. Very good. Okay. All right, we'll do one more here together, and then I'm going to have you guys finish two more on your own here. Okay. F of x equals x to the third. Okay, the function we just talked about earlier, right? I have a little picture there on the board, but we'll do it right here too. Okay, let's change that 2 to a 3. Graph it. And there's our swoop there. Okay. And let's go to Phoenix. Phoenix, what is the domain for this function? Beautiful, exactly right. Well done. Okay, so you'll notice a pattern here, right? All of our polynomials have had domains of negative infinity to infinity. Not super interesting, all right? But the ranges have changed up a little bit. So have the end behaviors too, all right? So let's see what happens here with this one. We'll continue writing, I guess, right? So let's go to Luke L. What's the range for this here, Luke L?
Would it be negative infinity to infinity?
Very good, sir. You got it. Okay, and now we'll do the end behavior. Okay, so as x approaches negative infinity, f of x is going to approach something. As x approaches negative infinity, f of x will approach something. Let's go to Jonathan. John, what do you say here, sir? So as we go further and further to the right, what are our y values approaching? Infinity. And as we go further to the left, what are our y values approaching?
Negative.
There you go. Very good, sir. Okay, just like that. All right. The next two I'm going to leave for you to do. So now I want you guys to do this, fill in the rest of this table. Bless you for x to the fourth and for x to the fifth as well. Okay. So you can use your graphing calculators. I'll also give you a hint. There's a pattern that's occurring in this table. Okay, there is a pattern that is occurring here in this table, but if you want to just use your graphing calculators and fill it in, that's fine too. Okay, but there will be a pattern that kind of arises here. That's why we're doing this. So you can see that. Okay, but if you don't want to, that's fine too. Okay, you can just use your graphing calculator. Go ahead, fill in the rest here. And, I would encourage you not to use pen if you can, just in case you make a mistake or something like that and you want to change it. But your choice. You guys fill in the rest. Fill in the rest of those blanks there. Again, use your graphing calculator. Anybody who needs a graphing calculator to borrow, let me know. Okay. Shane, you're all right with this stuff? Okay. Like your shoes, Jacob. Good. Looking good. Just talking. Yeah. I hear you. For jobs. Yes. Good for you. Oh yeah?
Yeah, this Friday.
Where are you applying?
Target.
Okay. Very good.
Just for this summer, yeah.
Mm-hmm. Any particular department you're hoping to get into?
Well, I'll apply for next year's.
Okay. You'll just take whatever you can get, basically.
Yeah. Right now, yeah.
I understand. One more minute here. 1 more minute. 1 more minute. Sure, yeah, you feeling okay on this stuff?
Yeah.
Okay. All right. let's go to Nick. Domain there, Nick, for x to the fourth. What'd you get?
Negative infinity to positive.
Negative infinity to positive infinity. Surprise, 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 right? Same thing we've been getting for all these earlier ones. So, yeah. Okay. All right, very good. Thank you. Let's go to Hannah. How about the range for x to the fourth? So it does go to positive infinity. Let's take a look here, though. I think it doesn't quite go all the way down to negative infinity. Let's see here. Let's graph this thing. X to the fourth. There it is. Okay.
Zero.
It is 0. Correct. It's 0. Yeah. And we do get there, so we're going to again put that square bracket. Okay. But there it is. All right. Very good. Let's go to. How about Michael? And you're the only Michael today. So, Michael, how about the end behavior here? As x goes to infinity, for x to the fourth, as x goes to infinity, f of x will go to infinity. And as x goes to negative infinity, f of x will go to infinity. And beyond, that's right. All right. Let's keep going here then. How about Avery, x to the fifth? What's the domain for x to the fifth?
Negative infinity positive infinity.
Yes, sir. That's right.
Yes, sir. Yes, sir.
Let's go to Luke P for the range here, Luke P.
That's also negative infinity, positive infinity.
That's right. Okay. And then the end behavior, and we'll go to all these people absent. I keep having to like skip around here. I don't know. Let's go to Chris. What's the end behavior here, Chris?
Infinity.
Okay, so as x goes to infinity, f of x goes to infinity. Okay. And as x goes to negative infinity, f of x will go to
Negative infinity.
negative. Okay, you got it, sir. Very good. Okay, so I know it's a lot of data here, all right, but let's kind of take some time and look at this table. So first of all, recognize, right, our functions, we were counting up by 1 for our exponent, right? We had x squared, x to the third, x to the fourth, x to the fifth. This x, when there's just an x by itself, what exponent could we give that?
X to the 1.
X to the 1. Yeah, when there's no exponent written, you can always give it like a 1, like that. Okay, so we start with a power of 1, then 2, then 3, then 4, then 5. Okay? The domains were all negative infinity to infinity. And that's going to be true in general for polynomials, right? That's kind of like what helps kind of classify a polynomial. It should be, going from negative infinity to infinity with the x values. There should be no x value. It's a problem. Later in this class, we'll see functions where the domain will not be negative infinity to infinity. There'll be numbers that we have to take out from our domain. And you'll see why when we get to that point, okay? The ranges, though, are all the ranges the same? No, but how many different kinds of ranges are there?
2.
Just 2, that's right, okay? And one of them is negative infinity to infinity. Do you see any pattern with the negative infinity to infinity ranges? Like, how does that connect back to these functions here? What about those functions maybe is similar about them?
I think the functions that have x to an odd number power, it's negative infinity to positive infinity.
Okay.
Always have an even number, 0 to infinity.
That, I couldn't have said it better myself. Exactly right. Okay. Yes. Okay. So the key here for this behavior that we're looking at, you can categorize the odd behaviors, and they all have the same domain, range, and end behavior, and the even behaviors all have the same domain, range, and end behavior. Okay. The evens go from 0 to infinity for their range. The odds negative infinity to infinity. And if you look at the end behaviors, the same thing is true. Okay. So x to the 1, x to the 3, x to the 5. Okay. For 1, 3, and 5, those powers. As you go to the right, you go up. As you go to the left, you go down. Right, up, left, down. Right, up, left, down. But then for the even ones, both ends, whether you go to the right or to the left, both ends go to infinity, go up. Okay? So that's going to be helpful for us here when it comes to graphing these polynomials. Okay? So we're going to be using this kind of idea to help us here. And I'll make a little table. I'll make another little table right here to help summarize all this. Okay. So we'll make two columns and 2 rows to this next table here. So I'll call this like an end behavior. Okay, table here. So you can use this to help you kind of like, think out the end behavior for any function you come across. Okay, so we'll say a greater than 0, a less than 0. Remember, a is that lead coefficient, right? Lead coefficient there. So if a is greater than 0, a is less than 0. And then we'll talk about the degree here. Okay, so we'll say odd first, and then even. Okay, now, when I say the degree for a polynomial, the degree, okay, you've heard that word degree before back in geometry, right, where you talked about, like, an angle is measured in degrees, right? But in algebra 2, when we talk about degree, at least for right now, we're going to refer to that as the highest power in the polynomial, the highest power that you see. Okay? All right. So, let's see here, and I'm going to fill this in with my pen, maybe so I can write kind of small here. Okay, so if we have an odd degree, positive lead coefficient, that'll be like our x to the fifth, right? That's a positive lead coefficient, right? It's positive 1 in the front, and then 5 is the power. And that's going to be this end behavior right here. So as x goes to, I didn't leave myself enough space for this. Shoot. Okay. Yeah, I did not leave myself enough space for this. Very tight. There you go. Okay, so as x goes to infinity, f of x goes to infinity. And as x goes to negative infinity, f of x goes to negative infinity. Okay, so that's as x goes to infinity, f of x goes to infinity. As x goes to negative infinity, f of x goes to negative infinity as well. Sorry, I'm trying to zoom in on that so you guys can see that okay. Okay, this one I'll have more space though. If a is less than 0, so if we have a negative a value, remember, what does a negative a value do? What kind of transformation occurs when you have a negative a value? Like if I throw a negative 1 in front of a function like this right here, what does that do to our function? Pete? Yes, flip over the x-axis. So our end behavior is going to flip as well. Instead of going to the right, you go to positive infinity. It'll be to the right and negative infinity, and then to the left, you'll go to positive infinity. Okay, so it flips the end behavior as well. So we can just say as x goes to infinity, f of x will now go to negative infinity. And as x goes to negative infinity, f of x will go to infinity. Okay. Just like so. Okay. And then let's talk about even functions, right? So even. All right, now the even ones, their end behaviors, they both go up, right? For x squared, whether you went to the right or to the left, both ends went up. Or the x to the fourth, whether you went to the right or left, they both went up. So same thing here is true as well, right? For any even function, even powered function at even degree, as x goes to infinity, f of x goes to infinity. As x goes to negative infinity, f of x goes to infinity. Okay. So then if a is less than 0, and we do that reflection like Phoenix mentioned, right? Instead of both going up, both will go which way? Down. Yeah, we're both going to go down. So as x goes to infinity, f of x goes to negative infinity. And as x goes to negative infinity, f of x will go to negative infinity. Okay? So if you want to draw yourself a little picture, for this situation, it's going to look like this. Okay? That's going to be our end behavior. For this situation, it'll look like this. Okay. For this situation, it'll look like this. Okay, and for this situation, I'm not going to have enough space, so I'll put it like that. It'll look like this. Okay. And there are all the end behaviors that we're going to have to deal with for our graphing our polynomials. Okay, and so that's the only like new thing we talked about today, because everything else that we need to do for these polynomials, we already know what we need to do. Like we already know kind of like what this is going to be. Okay, so we don't need anything else. We're just going to add this on to what we already know, and now we can graph any polynomial we come across. Well, not any polynomial, but we'll be able to graph some of these polynomials here I'm going to have you guys do today. Okay. We'll talk about other strategies and techniques we need to use in a little bit, but right now this is the easiest for what we need today. Okay, so keep that table there handy, and let's talk about actually graphing a polynomial. Okay. So, let's do one here. Let's sketch the graph of f of x equals x parentheses x plus 2 parentheses x minus 3. Okay? We're going to actually graph this. No calculators, okay? We're going to do it without a calculator, and then we'll check to see how we did with the calculator. Of course, you guys will always have the calculator available to you, so you don't have to worry about, not knowing what it's going to look like, but it's helpful. Let's do it without a calculator for right now. Okay. First, I'm going to leave this space right. Actually, you know what? I'll go ahead and just do this work right here. So let's first talk about the end behavior, because that's what we just finished discussing, right? Okay. What is the highest power in this polynomial going to be? Hey, what's the highest power in this polynomial going to be? What do you guys think? What's the highest power in this polynomial going to be? What's the highest power you see right now? X to the what power? 1, right? That's x to the 1. Right, that's x to the 1, that's x to the 1, that's x to the 1. But they're written as a product. Right? There's multiplication there. When you have x next to something and these two things next to each other, that's written as a product. So when we if we were to multiply these, what would be the biggest exponent that we would see then? What is it? 3. Exactly right, Avery. Yes. This x will multiply with this x and the 2. Right? And then that's going to multiply with this x minus 3. But eventually these three x's are going to have to get multiplied together. So what we're looking at here is an x to the third. Okay? So the degree here is going to be 3. All right? The degree is 3. What about the lead coefficient? What's our a going to be? Again, imagine multiplying this stuff out. Is a going to be positive or negative? Negative. Positive? Right. Which one is it? Well, again, think about the same way that Avery did with the x's, right? He had x times x times x. That gave us the x to the third. Look at the numbers in front of the x's. What's the number in front of this? What's the number in front of this x? 1. What's the number in front of this x? What's the number in front of this x? 1 times 1 times 1 is 1. Positive. So in other words, our a value here will equal 1, and that's greater than 0. Okay, so we have an odd degree, and a is 1, which is bigger than 0. Okay, so odd degree, a is bigger than 0. A is positive. So this is what our end behavior is going to be like. To the left, we should go down. To the right, we should go up. So that's what our function's end behavior will look like when we finish graphing here. Okay? So I'm going to write that out. As x goes to infinity, again, I'm just going to use this right here. Okay? F of x will go to infinity. Okay? And as x goes to negative infinity, f of x will go to negative infinity. Okay, so as we go really far to the right, we go up. As we go really far to the left, we go down. All right, but the problem is we have the end behavior. We don't know what's happening in between, right? And here's how we're going to figure that out. Okay, we're going to find the zeros next. Okay, we're going to find the zeros next. Okay, so there's our end behavior. We're going to use that in a second here. Okay, again, it's going to look something like this. Okay, so the zeros. To find the zeros, we're going to set our function equal to 0. Okay. Now, we've solved quadratic equations when they're equal to 0, right? But here we have, this is like a cubic, I guess, right? Because x times x times x. But still, the principle is the same. We have 3 things that multiply to give us 0. When your product of these 3 things is 0, that means each one of these 3 things could or must be 0, right? So we could say x is 0. We could say x plus 2 equals 0. Or we could say x minus 3 equals 0. Okay. X equals 0, we're done. So there's one of our zeros. And then to finish solving here, we'll just subtract 2 from both sides. So we get x equals negative 2. And then here we'll add 3 to both sides to get x equals 3. And those are our zeros right there. So now we know where our graph crosses the x-axis. Okay, so let me go over to my graph. Let's start graphing this thing. Now we kind of have an idea about what's happening here. I'm going to start graphing this. Okay, it might seem a little preemptive, but no, I think we're okay. We can start doing this. Okay, just like that. And I'll do this in red so that way it stands out. Or maybe green. I did get markers. Where did I put them? I put them back here. Okay, so let's plot these zeros. So a 0 at 0, so a nice big point there. At negative 2, nice big point there. And at 3, 1, 2, 3. Okay, like so. I don't know what green does it, but oh well. Okay. So we have these 3 points. We also know our end behavior. So as I go really far to the right, so I'll go to my rightmost 0 right here, and I know I need to go up to infinity. So I'll kind of draw like a small, kind of like part of it right there. And then as I go really far to the left, so my leftmost 0 right here, I need to go down to negative infinity. So I'll point down from there. Oops, I put an arrow there this time. Oh, I guess I'll do it there too. Okay. So we know that kind of have to be our ends. So there's our end behavior. But we need to know what happens in between too. Okay. We need to know kind of what happens in between, right? I could go up and back down, but I could also come up, touch this, come down like this. I could go down between these 2 points too. I could come up, kind of bump off the x-axis like this. So I could go up and down, or up, bump, and back up like that. Okay? So we need to figure out what's happening between. So how are we going to do that? Well, you can call this maybe like the middle behavior. Okay? Okay. What x value is between these 2 zeros here that we could use to help us? What's an x value between these 2 zeros we could use here? Yeah, negative 1. So let's plug in f of negative 1. Okay. So we'll plug in negative 1 there. So it'll be negative 1 into the function right here. So we negative 1 times negative 1 plus 2 times negative 1 minus 3. Okay? So I'll just do this in my calculator. Negative 1, parentheses, negative 1 plus 2, parentheses, negative 1 minus 3. Okay, just typing it in, hit enter, and I get 4. Okay, so I'll go ahead and plot that point too. I have the point negative 1, and I got the y value of 4. So negative 1, 1, 2, 3, 4, right there. Okay. So now I know I have to touch this 0, go up, hit this point at least, and come back down. Okay. And then f of 1. So now let's try 1, because again we need to figure out what's happening between these two zeros. So I'm using the x value of 1. What other x value could I have used here though?
2.
Yeah, 2 would be a good one too, or anything between 1 and 3. Anything between 1 and 3. So I'm just going to use 1. So again, I'll plug in 1, 1 plus 2, 1 minus 3. Okay? And so that'll give us negative 6. So we have the point 1, negative 6. And I'll plot that. 1, 1, 2, 3, 4, 5, 6 right there. So we have to go down to here and come back around to the 0 there. And then you can continue it on if you want to like that. Continue it on like that if you want to as well. Okay, and there's a sketch of our graph. Okay. And of course, you're welcome to use your table on your graphing calculator if you want to help you figure out these points in between the zeros. Right? So plot your zeros, right? And you can figure out some more points using the table on your graphing calculator. You're welcome to do that. I do have a confession to make though. Okay. This graph is only a sketch, and it's not very accurate. Okay, for example, this point, it looks like the highest point right here, it looks like it reaches a peak at negative 1, 4, and it looks like it reaches like the lowest point right here at 1, negative 6, the way I graph this, but actually, that's not the case. If I actually graph this here on my graphing calculator, and if I do second trace and I go to maximum, I'll go to the left here, hit enter, go to the right here, hit enter, and then go up to the top of it, hit enter. You'll see that that highest point does not occur at negative 1, 4, right? The actual highest point occurs at negative 1.119634, and it's a y value of 4.0606726. That's not a rounding error on the calculator part, that's for real. Okay, so we're estimating this peak here. Same thing with this valley. If I use my graphing calculator, second trace, minimum, go to the left, hit enter, go to the right, hit enter, go to the bottom, hit enter. You can see again, it's like 1.786, and the lowest we get is negative 8. Whereas here I have the point 1, negative 6. Right? So we actually go a little bit lower than this and to the right. Okay? So, how are we supposed to find these actual peaks and valleys? Well, you can use your graphing calculator if you want to. That's one option, right? The other way to do it without a graphing calculator is to use calculus to do it. Okay? And it's not too crazy, but it is pretty, you know, it's more, it would be more to learn and stuff like that, and that's why we're just going to do it this way with our best sketching kind of thing. Okay. So yeah, that's how we're going to be graphing these polynomials. Right? End behavior, using our table up there to help us out. Zeros and middle behavior. Of course, you guys will always have your graphing calculator, so you really could get a good idea of the sketch just by typing this in your y equals and hitting the graph button too. Okay, so that's available too. But I just wanted to show you all this full analysis without it. Okay, I would encourage you to try doing this without your graphing calculator. See what you can do. Okay. Do you guys want to? Yeah, go ahead. You guys want to try one on your own? Do we need to see another one? Does anyone like, Mr. Witt, I'm still not getting this at all. I need to see another one. All right, let me have you guys try one here on your own then. So you guys try this one. Okay, I'll give you f of x equals negative x squared times x minus 4. Okay, and again, I would encourage you to type in your calculator just like you see it here. Don't put parentheses on the negative x. Make it negative x squared and then x minus 4, just like you see right here, and that'll get you to graph it right. Okay. Please do identify the end behavior for me. You can use your graphing calculator to help you if you want to, or you can use that table we made. And then identify the zeros for me. Again, you can use your graphing calculator to do that if you want to, or you can do it by setting it equal to 0, your choice. And then give me some middle behavior there too. What happens between the zeros? Okay, so go ahead, and then you can just put the graph right here. Yes, go ahead. So see what you guys can do. See if you can do it there. Okay. Yeah. So when you multiply your x's, then you add their exponents. So yeah, it's a 2 and a 1, so that should make 3. Yep. Good question. Good question. Oh, one second. Yeah. Absolutely. Oh, there it is. Yep. If you caught it, that's good.
Yeah.
And I set up the scale there for you too, or I didn't really change the scale actually, but what my graphing x and y axis will look like there is. Bless you. All right, you're like 30 more seconds here. Well, hold on. One more minute. Here we are. Okay, perhaps it looks something like that. Maybe I should fill it in better with my thicker pen here. So you should have a 0 at 0, 0. Okay, and then again, the next 0 should be at 4. You go up between those two zeros. Okay, like so, and then you're going to go down like that. Okay, so right here, this 0, the graph kind of comes, bumps off that 0, and goes right back up. That end behavior, right, indicates we go right back up there. And then here from this rightmost 0, we go down from there, right? That's our end behavior. Degree is 3, right? X squared and x to the 1, that adds together to make 3. Because when you multiply, you add your exponents. Okay, and so there's our end behavior. The zeros, again, you set the negative x squared equals 0, the x minus 4 equals 0 because it's already factored nicely for us there. So 0 and 4. Okay, and then we get the middle behavior there. I picked the number 2, plugged it in, got 8. Right, and there it is. Questions on any of that? All right. If not, then I'll get you guys started here on your assignments. All right, and I won't give you a ton of these because I know they can be a little bit of work, but you do have your graphing calculators to help you, so please feel free to use that, to your benefit. So, it'll be out of section 5.2. Okay. Let's get the right page numbers here for you. Here we go. Starting on page 188. Well, do I have you start? No, I have you start there. I have you start really on page 189. So 5.2 numbers. 9, 10. And 14 it looks like. I think that's it. Yep, 3 problems. That's it. Okay, so you guys have 15 minutes to get 3 problems done. All right, so let's do that, though. Of course, you're graphing these polynomials. You'll maybe want to use like the graph paper on your notes, okay? Or if you want to grab another piece of graph paper, feel free. But there are books over there if you want to borrow those, okay?
Yeah, it's unfortunate there's no set today.
I know. But I can get you started at least right now, Luke, if you want to.
Yeah. I'll do as much as I can.
I'm saying maybe get a little bit further. Yes.
We have drill today.
The drill, the avoid, deny, defend drill is today. So move. There will be set, just no movement. So, here we go, Luke.
No, after today, there would definitely be 7 less than this, so, but I just want to try to get a little further today.
Yep. Chris, would you like to work more on your test?
Yeah.
You can. There's no movement today, but then tomorrow I can put you in. Sarah, would you like to work on your test instead? Maybe. Avery, do you want to continue working on your test?
Please.
All right. You mind just like scooting over so I get a different spot?
I'd love to do this real quick.
Yeah, if you want to, that's fine. Put away, please.
Yeah.
Thank you. And if you have a question, or Christian, you want to ask me or something like that before you get started, then ask away too. Yes.